Excellent, we're live again. Awesome. Today is Friday the 8th. So we have today. We have 2 days next week. We have 2 days the week after. That's 5 class periods until your midterm examinations. Of course, of those 5 class periods, I want to go at least 2 of them or so to review. So that's really 3 class periods we got left to go. Now, on the computer, for those of you that are live, I'm going to be posting a PDF for you to utilize during the course of this particular class period. Actually, 2 PDFs. Everyone in the classroom already has the PDFs for today. Click. Boom. There we go. So for those of you that are online, you can access them there. And this is where I want to start. Now, for the sake of argument, in order to get the first part of this done, I am going to ask that you do have those Chromebooks out and open, because you're going to need the graphing calculator to do what I need you to do. The graphing calculator is going to get part of the graphs done for you, and I'm going to show you how you're going to utilize them in order to get accurate graphs. But of course, you need to get them out and logged on. And then for those of you that are with us right now, you're with us right now and you're already on a computer. So I'll give people a few moments to kind of log on while I bring up my calculator. There we go. Come on, you. There we go. So let me clear that. Turn that off. Clear. Oh. Clear that out. Zoom that back. Excellent. Good. So for example, I'm looking at something like number 2. And I want to go into the details of number 2. I'm on the 6.3 worksheet, and I'm looking at number 2. Now, number 2, they're asking for you to graph this particular thing. Now, I am going to type that into my calculator, into the y equals key, because I would like to get certain pieces of information out of it. And I'm going to show you exactly what I expect of you in regards to graphing this thing, because I need a little accuracy. So you do need to get the practice with typing these things in, because the y equals key and the square root function, it's a little bit weird the way that it works. Oh, sorry, I'm stuck on your foot. I'm stuck on your foot. There you go. So if I'm going to type in a problem like number 2, first I would go negative. You don't want to type in the minus sign. The minus sign, I believe, would get you a syntax error. And then square root. Now, what's weird about the square root on these calculators, if you were on the TI-83, then, yeah, you would have a parenthesis that would open up. But on this one, they just have this little dotted box thing going on. Whatever. But I'm going to have to put in x minus 1. And now there's nothing after it. Sometimes there will be a number written after it, which we will do number 5 in a little bit. But this is how number 2 would be typed in. Now, yes, you can hit graph, and we can take a look at what the heck is going on, and you get this thing right here. If you hit trace, I believe you should be getting the same numbers that I'm getting right here. When you hit trace, do you get x equals 0 and then y equals blank? Maybe? Kinda? Okay. Is that what happens on your calculator, or does something else pop up? The what? Had to hit trace? Had to graph it? You go to y equals. You type in the equation. And then you hit graph. Now, what's interesting about this, and I'm going to write this equation on the board. And like I said, be careful, because if it's a negative in the front, you actually have to use the negative button. But inside the square root, you have to use the minus sign for x minus 1. It's like very, very key things you got to know how to do on this thing when typing these equations in. Now, this equation is y equals negative square root of x minus 1. Last class, we spent a bit of time talking about what the numbers on the inside and the outside do to your typical square root function. The number on the outside, more specifically the negative in front of the square root, is going to cause a vertical reflection. The negative in front of the square root is going to cause a negative reflection, which is why this square root function is opening down. Remember, it's like a parabola on its side. The number on the inside, x minus 1, well, let me write this as well. We wrote this down last class. I'm going to write it down again. This is the general form, or the standard form, I should say, of a square root function. X minus h indicates that your h value is a positive 1. As we wrote into our notes, I put a little bullet point on there saying that you had to pay close attention to the sign that was on your h value. These are all in our notes from last class. Now, because it's x minus h, that negative is already taken into account. It's x minus 1. Your h value is positive 1. Now, if you notice right here, this equation does not have a k value, which is why the k value is 0. When it comes to graphing these square root functions, we need to identify a few different things. If we can identify the values of h and k, then we know where this thing starts. If we can identify the value of a, then we can determine what direction this thing is going. Hit in your calculators, second graph. Hit second graph. We're going to go to a table of values here. Hit second graph. If I hit second graph, takes me to that table of values. I'm going to erase some stuff on the board so we can see this a little bit more clearly. But if you notice immediately, 0 gets you an error. 0 gets you an error. There's a reason for that. 0 automatically gets you an error. Yes, the graph doesn't exist at 0. But more importantly, if you plugged a 0 in for x, you would end up with the square root of -1, which is a complex number, which would introduce I, but we're not graphing that. We are not graphing that whatsoever. So here's what I need. We're about to graph this thing on this worksheet. But I don't feel like plotting all of these little decimals. I don't feel like plotting all of these little decimals. So instead, let me show you exactly what I expect of you. On this worksheet, I'm going to flip my camera over in a moment. There it is. Chapow. Zooming in, zooming in, zooming in, zooming in, zooming in. There we go. I'm going to ask that you create a little table of values off to the side like this. Create a little table of values off to the side. Now, this table of values is going to help us with our accuracy. We are going to get accurate data points on here. And where are you going to get those accurate data points? You're going to get them directly from this table of values. You're not going to have to worry too much about having to calculate them by hand or guess what they're supposed to be. Go to your table of values. But the decimals are not necessary. Instead, I'm going to write down a few ordered pairs here, and then I'm going to flip my camera over to show you. There we go. Boom. Those are the only ordered pairs that I'm writing down. I am only going to write down those ordered pairs because those are the ones that make more sense to me. They're the whole numbers. And you can do the same when it comes to these types of problems. Now, we'll talk about domain and range in a moment. But first, let's actually try to graph this thing. So I'm going to plot 1, 0. I'm going to ask you to do the same. Of course, if you're doing this at home, you can just create an XY plane and whatever notes you're working on. 2, -1. 3, 4, 5, -2. Now, 10, -3 is actually going to be a little bit off our graph. I can just approximate where it's supposed to be. 6, 7, 8, 9, 10, -3. That looks about right. And according to what we know about square root functions, I would draw this curve attempting to go through all those points. I'm having a terrible time trying to draw a nice little curve right here. Just trying to go through those points. But that's what that thing would do. The square root function is a parabola on its side. It's half of a parabola on its side. So if you imagine, I can turn my paper right here. You can kind of see half of that parabola now by turning it sideways. Yeah, that's what I want. It should be curved. It should be like a half a parabola on its side. Now, talking about domain and range is a slightly different story. We've talked about domain and range in the past, but this one is going to be slightly altered. Domain is the list of all possible inputs. Now, the thing is, I can't input everything. If I go back to my table of values right here, clearly I cannot input 0. If I try to input 0, I get an error. And anything beyond 0 to the left, nothing but errors. Those numbers are not in my domain. They are absolutely not in my domain. But if I go to my graph, I'm thinking inputs. I'm thinking X values. The farthest left that my graph goes on the x-axis is +1. And the farthest right it goes, well, it keeps going forever. And I am going to put something like this into my notes in a little bit. But look what I just wrote for my domain. Look what I just wrote. That is a 1, infinity. Let me repeat that. That is a 1, infinity. But pay close attention to the symbols that I put around them. Typically, when you're talking about domain, people like go, -infinity to infinity, some junk like that. But we need to put a bracket around that 1 because it actually reaches the 1. It actually touches the 1. 1 is the absolute minimum on the x-axis that this graph reaches. To the right, it goes forever. 1 to infinity with a bracket around that 1. But then I got to talk I got to talk range. If I'm talking range, this gets a little tricky here. Let me write it, and then I'll talk about it. There it is. There's my range. There's a reason for that. I want to talk about that reason. Typically, when you are talking about range, you are talking about how far up and down the graph goes. When you are talking about range, you are talking about up and down. When you are talking about range, you are talking about the y values, the graph according to the y-axis. How far down, how far up does the graph reach? Well, in terms of going up, visually, you can literally see it only goes up to a y value of 0 on the y-axis. That is the highest y value that this thing reaches. But with square root functions, this thing will keep going down and out forever, like a parabola. So technically, and I can show you this on the table of values, but this thing will keep extending down forever. When you express range, you go lowest to highest. The lowest point, it's headed towards negative infinity. The highest point, it reaches 0. That is the range of this particular graph. It's a little strange, but that's what we got to do with this one. Here's what I would like to do. I want to get you started on number 5. Then I'm going to have you complete number 5 on your own. I'm going to get you started on number 5. I'm going to show you what this thing looks like in the calculator. Hopefully you'll follow along and type it into the y equals key. But then you are going to find a table of values. You are going to try and graph this thing directly on that paper. And you are going to identify the domain and range. So let's see what number 5 is going to get us. I'm looking at number 5. We'll go back to my calculator here. Clear that out. Number 5 is the square root of x plus 7. Now, again, I still have to put in that minus 4. But again, notice how the calculator is oriented. That minus 4 is not inside the square root. That minus 4 should be outside the square root. So I'm going to have to hit the right arrow key to get out of that square root. And then I just type in minus 4. It fell. But that's the way that thing should look in your y equals key. So, take the next few minutes. I want you to create a table of values. I want you to graph this thing out. And I want you to identify the domain and range. Now, just as a side note, I would suggest backing up your table of values to what I have up here. Take the next few minutes. Let's do it. let's see where this takes us. First, typing that thing into my calculator allows me to get that table of values. Again, make sure that you're typing this thing in correctly into the y equals key. Oh, and then I'm going to go to, there it is, my table of values. Second graph will bring me to my table of values. I'm not going to write down every ordered pair. I'm just going to write down the ordered pairs that I need. Ordered pairs that work out quite nicely in this table of values. Mr. Markey, how many ordered pairs do we need? It depends. It depends on how many would get you an accurate graph. And it seems to me like these numbers would work best, especially with what they've given you. So I'm going to take those numbers and I'm going to plot them. Now, just for the sake of argument, the A value of this graph is a positive 1, meaning that this square root function should be going up after I graph it. The H value, because it's x minus h, the H value should be a -7, which I know that it is based on the table of values, and my K value is a -4. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4. -7, -4, that is my starting point. And of course, I can see that on the actual graph itself. -6, -3. -3, -2. And then was that +2, -1? Yeah, that was +2, -1. Weird. But that's what my graph does. There's the half of a parabola on its side. Draw this thing out. That worked a lot better. Look at that. I actually went through the points that time. That's the table of values that I need. That's the accurate graph that we're going to do. Still need domain and range. Domain, remember, left to right, lowest to highest, x-axis. The farthest left that my graph goes is -7. The farthest right it goes is to infinity. Infinity and negative infinity will always have parentheses on them because they'll never reach it. The -7 in this case needs a bracket because the graph will actually hit -7. Whereas my range is lowest to highest, y-axis, vertical outputs. The lowest value that this graph reaches on the y-axis is -4, and it goes all the way up to infinity. That would be the proper domain and range. There are alternate ways of expressing that domain and range, but this is the most generally accepted form of expressing domain and range. But this would be an accurate graph. Well, the first graph, if I could look over here, absolutely does what you're implying.
Oh, okay.
Yeah.
Yeah.
It all has to do with whether or not the graph is going up or whether it's going down. Absolutely. And just as a reminder, what determines whether the graph goes up or down?
Well, like the numbers, like,
But which specific number, though?
well, for the bottom one, -6 and -3. Right?
Where's neg? Oh, you're talking about the ordered pairs.
Yeah.
I'm talking about the equation. Let me zoom in on this equation. This equation, if I can point my pen right there, there's my A value. Do you see it?
Yeah.
You do? I don't.
Oh,
I got you there. But the A value technically is there. You just can't see it. What is the A value? Not for this one. I'm not talking about the square root. I'm talking about what's in front of the square root. Here, let me walk up to the board real quick. I'll show you what I mean. Check this out. Remember, the A value is in front of that square root. Now, that's actually a very interesting point that you brought up. How do you get to that screen? I'll show you in a minute, Joe. Very interesting point that you bring up. You were talking about the little number in that little crevice. That's the second half of today. If you take your worksheet and actually flip it over, you'll see what I'm talking about. Heck yeah. But that's the second half of today. The first half of today, we're just dealing exclusively with these square root functions. But this A value determines whether it will go up or whether it goes down. In this case, this is a positive 1 that is in front of that square root. Thus, that thing is just going to be the top half of that half parabola. Whereas, nope, there it is. That's a negative 1, causing it to go down. The A value will determine whether or not the graph will go up or down. If the A value is negative, it will force a vertical reflection. Now, somebody in the chat, Joe in the chat, asked me how I got to a certain screen. I don't know what screen he's actually referring to. I'm assuming he's talking about something on the calculator. Joe, if you're talking about getting to the table of values on the calculator, then you have to hit second graph. Y equals will take you here, where you got to type in the equation. But second graph will take, second graph will take you to the table of values. I hope that worked. Okay. One more thing I just want to show you on this, just something really messed up that I think, I don't know, you may or may not enjoy. Look down at number 8. Look down at number 8. Zoom out, zoom out. What's so wrong about number 8 compared to what we've done so far? What is so different about number 8? So strange and unnerving about number 8? There's no equal sign. Now, the directions don't say anything about domain and range, thankfully, but there's no equal sign. Check this out. I'm going to show you exactly how to do this. Everyone go to your y equals key. Go to your y equals key. Now, I'm going to clear that out. Boom. And I'm going to type in exactly what number 8 is asking me to do. Square root of x minus 5, tab to the right, plus 4. Now, there is no equal sign. It says less than or equal to. Watch what I'm doing up here. I need you guys to do the same thing. Check this out. Look what my calculator is highlighted on. I did that by tabbing over to the left. If you hit enter while highlighted on that, you can change the type of line that you have. I don't care about the color here. The color could be whatever the heck it wants to be. But look what's happening here. If I go down to line and then just tab right, I can cycle through a bunch of options. These two options are the ones that I am interested in. This one that I stopped on is less than. Oh, I hit the wrong button. There we go. That one is greater than. The way that you can typically tell is where is the little shaded triangle? Is the shaded triangle kind of uppish or downish? Downish, in this case, refers to less than. If I hit OK on that and then go back to graphing it, there it is. That weird looking shaded region represents what I need to do. There, right there, that little curve that I just drew, that is the square root function. But because it's saying less than, I am going to have to shade in that direction. Shade everything that is less than my square root function. So I'm going to do that on paper. First, I'm going to go to the table of values. Oh no. So let me go back to my table of values. Second graph. I get all those errs. Well, I know where this thing is supposed to be. There it is. I know that's where it was supposed to be. I'm going to I'm going to write out some of these ordered pairs, not all of them. 5, 4, 6, 5, 9, 6. That's sufficient. I'm not going to write out 14, 7. Writing out 14, 7 would kind of be overkill at this point. Let me plot those. 5, 4, 6, 5, 9, 6. Now, there actually is a difference between whether or not you have the or equal to or not. I'll get into those details another time. But for now, all that you have to worry about is this. Literally just shading in everything that's less than it. Oh, happy day. That's literally all you have to do for that problem. You don't have to do anything with domain and range because they don't ask for it. You draw the proper square root curve as we normally did. Find that table of values using the graphing calculator. You could easily determine where you're supposed to shade. Well, less than means below and greater than means above. But of course, you could do it directly in the graphing calculator by changing that y equals key, where you go over to that blinky thing all the way to the left and change that up. It's a weird setup, but that's what it does. Okay. We are going to pick up with more of this next time, but for the remainder of the time that we have, I want to talk about what's on the back of this worksheet. I want to talk about what's on the 6.4 side. So, what I'm going to need from you, and please keep the Chromebooks ready to go. Keep the Chromebooks ready to go because there are some things that I have to show you in that calculator. But for now, I'm going to need those notebooks out and open. Keep those Chromebooks handy because that calculator is going to come in handy. Let's see here. Let's zoom out here. Yep. Let's call this nth roots. And yes, I did not stutter. That says nth, N-T-H. Nth. Nth roots. This, let's put a variable on the inside. This is, quote, the square root of x, end quote. We know this. This is stuff that's going back years and years and years and years and years. Square root of x, done and done and done. Okay. But now we have something like this. Quote, the cube root of x. See, the thing is, as he was implying earlier, that little number does change something. Typically, you assume that that is a square root symbol. Well, it's only a square root symbol if there is no number in this spot. If there's no number in that little crevice of the square root symbol, which actually is called the radical, if there's no number there, then you automatically assume square root, and you would be correct. But if a little number is written in that little crevice, then you can no longer assume that it is a square root. It is a different type of root. In this case, it is a cube root. Now, after cube root, you can pretty much have any root you want, which I'll go into a few examples. But for example, you would call this the fourth root of x, end quote. There's a little 4 there, you call it the fourth root. Anything after cube root, and you can pretty much call it like fourth root, fifth root, sixth root, things like that. 10th root, 15th root, doesn't matter. They're all roots. Give me a perfect square. Any perfect square. 9. Okay. The square root of 9 equals 3. Yeah, we did it. Why? Why is the square root of 9 equal to 3? You know that the square root of 9 is equal to 3, but how can you verbally show me that it's equal to 3? Why? We do know it's equal to 3, right? All right. Just anyway. But why? Why is the square root of 16 equal to 4? Why is the square root of 25 equal to 5? Why is the square root of 196 equal to 14? Why? I don't know. I guess it's a mystery. I'm going to put a different problem up here. Let that linger in the air for a few moments. What's the cubed root of 27? He says 3. I agree. Why? You're correct. Now that's interesting. First of all, the square root of 9 is equal to 3, to go back to the previous question, because 3 times 3 is equal to 9. Yes, the cubed root of 27 is also equal to 3, because 3 times 3 times 3, as he says, is equal to 27. That is how these roots work. That is how they work. They work on a system of basically doing the inverse of raising something to a certain power. It's the inverse operation. 3 cubed is 27. Thus, the cubed root of 27 is equal to 3. Check this out. This is an anomaly. This is actually a little bit of an anomaly. It doesn't happen all the time. The square root of 64 is equal to 8. We know that. What about the third root of 64? Do you know what the third root of 64 is off the top of your heads? Can you think of a number when multiplied by itself 3 times will give you 64? 4. It's a little bit of an anomaly. Now check this out. This is really going to mess with your head a little bit. What about the sixth root of 64? What is the sixth root of 64? Holy crap. It is a whole number, by the way. It's 2. Yeah. Just as a side note, I can't get it to be 1. I can't get it to be 1. The reason why I can't get it to be 1, well, think of it this way. 8 squared is 64. 4 cubed is 64. 2 to the 6th power is 64. 1 to what power will give you 64? Nothing. You can't do it. So I'm just saying it was like 8, 4, 2, and then I can't go any farther. You know, I can't do it, unfortunately. But that's what that thing does. Ah, so weird. It's so stinking weird. Now, check this out. Check this junk out. It's about to mess with your heads. I want you to type that into your calculator. But when you type it into your calculator, make sure that you put the 2/3 fraction in parentheses. This is 64 to the 2/3 power. Make sure you put the 2/3 in parentheses. Now I'm going to do the same thing over here. Clear that. Now, clear that. Put that back to normal. Come on. Just want you back to normal. There you go. Let's see here. Clear. What y'all got? Y'all get 16? Cool. This calculator actually doesn't require parentheses. I mean, my calculator, my 83 did. Because you could do 2 divided by 3 like that. It still works. Whatever. But you get 16. And the reason for that is this. There is a certain process that you walk through when you are taking certain roots. There is a certain process that you walk through. Now, you may not understand why that this is what it is at the moment, but check this out. The cubed root of 64 is 4. And then 4 squared is 16. This calculation is actually asking you to perform 64 to the 2/3 power, meaning cube root it, then square it. That's what it's actually asking you to do. 64 to the 2/3 power is actually asking for you to cube root it, then square it. Here's a definition that I got to have you write down. I got to have you write this down as a definition right here. Check this out. A to the m over n power. A to the m over n power is equal to the nth root of A raised to the m power. Move that up. There we go. A to the m over n power is actually the nth root of A, the whole thing raised to the m power. In fact, I just want you to imply this over here. Check this out. M over n is equal to the phrase power over root. That fractional exponent, m over n, whenever you see that, I need you to think power over root. The top of the fraction is the power. The bottom of the fraction is the root. If you can remember power over root for fractional exponents, you will be a leg up on so much of this stuff. Let me go back to my calculator ever so slightly. Check this out. Go back to your calculator as well. You'll like this. On the far left column of your calculators, there is a button called Math. Let's all hit that. Math. Now, what's nice about this math function in your calculator is that you actually have a dedicated cube button. You have a dedicated cube button, which is nice. You also have a dedicated cube root button. And you also have a dedicated nth root button. Go down to that function, function number 5. Go down to function number 5. Now, if you go down to function number 5, look what it gives you. It gives you exactly what we just talked about. I could type in the 6th root of 64. We know that the answer is 2, but now you can actually confirm it right there. Here's another way you can confirm it. The 6th root of 64 is actually equal to this calculation. Look what I just typed in. The 6th root of 64 is actually 64 to the 1/6 power. Spits out that answer. Just spits it out all over the floor. Blah. It's very strange. One more thing that I do have to show you. One more thing. And we're going to do this on the calculator in a moment as well. But I want to write down one more thing. I did not miswrite that. That is exactly what I wanted to write down. The square root of negative 64 is a non-real answer. It's a complex solution. It is. There's nothing we can do about that. It actually does get you the I that we talked about earlier on in the school year. However, the cubed root of negative 64 does get you an interesting answer. Let's go to our calculators. I'm going to go math. Actually, you know what? I'm just going to pick the cubed root 1. I'm going to pick the cubed root 1 because it's a cubed root number. And I'm going to type in negative 64. Negative 64. Now, we know that if we did the square root, it would be a non-real answer. But if we do the cubed root, you get negative 4. Why? Why does the cubed root all of a sudden actually give you an answer? The cubed root of a negative? I thought you couldn't take the square root of a negative. Correct. You can't take the square root of a negative, but you can take the cubed root of a negative. Why? Why? For the sake of time, I'm going to have you write this down into your notes. My whole thing. Anyway. For the sake of time, I'm going to have you write this down. Because negative 4 times negative 4 times negative 4, a negative times a negative times a negative. The first two negatives cancel each other out. But when you end up multiplying by that third negative, it results in a negative answer. Ultimately, it comes down to the following fact. When you take even roots, meaning square roots, fourth roots, sixth roots, if you take an even root of a negative number, you get I. There's nothing you can do about that. But if you take an odd root, fair game. You're allowed to. Perfect. For this reason. It's really strange, but I love it so much. Next class, Tuesday, I'm going to expect these worksheets to be back because I'm going to be working off of these worksheets. Of course, those of you that are online, you already have them because they're in the Google stream. Yeah. But I am going to expect these worksheets to be back because we will be working off of the 6.4 side of this worksheet. Pay attention to Google Classroom because you never know when something is going to pop up. We will be knocking out an assessment next week on some of the concepts of this chapter that we've been covering so far, but we'll get there when we get there. Bell's going to ring in approximately 1 minute. I'm going to sign off. I have nothing witty to say, so I'm just going to say, woo.